Alright, in today's class we are going to be looking at terms in a GP, end term of a GP. Okay, what is it all about? The end term of a GP means the general term of a GP. Okay, the general term of a GP. But before we do that, let's first of all consider the sequence, which is of course a GP. The sequence below. We have, let's start with, let's say 4, 8, 16, 32, and so on. This is a GP. How do we know this is a GP? We know this is a GP if we take the ratio between two consecutive terms, a term divided by its preceding term, and we find out that the ratio is the same throughout. So we know that is a GP if this is a GP, this is a GP. If R is the same thing as 8 over 4, for all the terms equal to 16 over 8 is equal to 32 over 16, and so on, right? Any term divided by its preceding term giving you a constant ratio means that the sequence is a GP, okay? That is it. So in this, the first term, 4, so this is always going to give you 2. This is always going to give you 2. 8 over 4 is 2, 16 over 8 is 2, 32 over 16 is 2. So in this, again, A, which is my first term, A is used to denote the first term, is equal to 2. So now we have established that this is a GP. What more do we have to do? We want to generalize GPs, terms in a GP, right? Or the end term of a GP. We now say, consider this particular GP. Okay, I will put them term by term, and then from there we generalize. Okay, here my first term is T1, my second term is T2, my third term is T3, my fourth term is T4, and so on. Can you see? So here my first term is A, which is simply 4. We have it as 4. The second term is what? Somebody? The second term is 8, right? 8. The third term is 16. The fourth term is 32. And so on. That is it. We do not know the end term. We do not know it. The end term, Tn. We don't know it. Okay, we don't know it. But we are going to find out an expression for it right now. Right now. Just study this pattern very well. So, now, in order to get the first term is given already. In order to get the second term, since we know that it's a GP, we simply say, see, my first term is still 4. My second term, what is the relationship between the second term and the first term? You see, this is the relationship. See, the second term is the first term times the common ratio, which is 2. See that? Times the common ratio, which is 2. The common ratio is 2. And then, next we have what? The third term. The third term is related to the second term such that I will multiply the second term, this is the second term, by the common difference, by the common ratio. See? So if I multiply this by the common ratio, I get this. Okay? Then this one, the fourth term, I multiply the third term by the common ratio to get this. We're going to have 4 times 2 times 2 times 2. See that? And now, what are we going to do? We're going to multiply this. How do we get this? We multiply the term before this by 2. So, the term before this normally is going to be n minus 1 times 2. But we're going to see that now. Okay? Right. So now, what do we going? Make sure you take your notes. Make sure you take your notes, please. Here we have 4. This is 4. This is now going to be 4 times 2 raised to power 1. Here is now 2 raised to power 0. You see, I'm generating the pattern now. I'm getting the terms now. So here is what? This is the second term. This is the third term. Third term is going to be 4 times 2 raised to power 2. This is 2 raised to power 2, right? This is 2 raised to power 2, right? 2 raised to power 2. And then this gives me 4 times 2 raised to power 3, right? Now, we can see what is happening. The nth term here is simply going to be 4 times 2 raised to power n minus 1. Simple, nothing more. And this is the nth term of this GP. This is the nth term of this GP. And so I can write it as T1 is equal to 4 times 2 raised to power 0. T2 is equal to 4 times 2 raised to power 1. T3 is equal to 4 times 2 raised to power 2, and so on. That means that I can get my T10 as 4 times 2 raised to power 9. Clearly from what we can see, the number here is always 1 more than the number here. The number here is always 1 short of the number here. See that? And so, therefore, my general term, Tn, is the same thing as A r raised to power n minus 1. This is what is required of you to know. This is what every student should know. Every student of mathematics should know that the nth term of a GP is given by this. And don't forget this. Okay? The next thing, we're going to solve some simple examples. Okay? We're going to solve some simple examples. Let's take a simple example. Okay, state the common ratio of the following. State examples. Examples. State number 1. State the common ratios of the following. The first one, we have 12 minus 4. 12 minus 4. Whole number 1 over 3. It's a GP. The next one is 1 over 2. 1 over 3. 2 over 9. The next one, C, is 10 whole number, 2 over 3, 16, 24. So, as simple as that. So, what's the first one? Solution. Solution. A. We have the GP 12 minus 4, 1 whole number 1 over 3. Common ratio, as we said, is a term divided by its preceding term. So we're going to have the common ratio here is going to be minus 4 over 12, or 1 whole number 1 over 3 over minus 4. In each case, we're going to have minus 1 over 3. See? That's the common ratio. Okay, the next one B. B, we have 1 over 2, 1 over 3, 2 over 9, continuously. The common ratio here is going to be a term divided by its preceding term. So here we have 1 over 3 over, let me write it like 1 over 3 over 1 over 2, which is simply or 2 over 9, 2 over 9 over 1 over 3. Okay? So in each case, R is going to be, see, this is going to be 2 over 3. In each case. In each case, R is going to be 2 over 3 if you work it out. Okay? So, C. In C, we have 10 whole number 2 over 3, comma, 16, comma, 24, comma, continuously. So in this, I can easily just use this 2 to establish my common ratio. But I can also use this, but this is easier to use, right? So common ratio R is going to be equal to 16 divided by 10 2 over 3 or 24 over 16. So we can clearly see that if you do this, you're going to see that in each case you're going to get 8 can go in this, 3 times 8 can go in this, so we're going to have 3 over 2. Right? Because 8 here is 3, 8 here is 2. This is how it's done. Okay? Let's take another simple example. Example number 2. Please, if you have any question, I would like to see the questions in the comment section below. Okay? I would like to see that. So, the next question. It says that number 2. Find A, the 12th term. B, of the GP, okay, of the GP of the GP 128, 128, 64, 32, continuously. B, a formula for the nth term. A formula for the nth term. Simple. Okay. Now, what we're going to do here, solution. We are given that the GP is 128, 64, 32, this is the GP. We are going to find the 12th term of this GP, and then we will now be able to find the general term or the nth term of that particular GP. What am I going to do right now? I am going to first of all establish or write down the formula for the nth term of a GP. Write down the formula as given earlier on for the nth term of a GP. So I'm going to say here we are going to have Tn for any GP, right, is equal to A R raised to the power n minus 1. We shouldn't forget this. This is the formula, right? Okay. In this, what are we finding? We are finding the 12th term. If you are finding the 12th term, it means that n must be 12. So here, n must be equal to 12. The first term is always this. A is equal to 128. That's the first term. See, we're done with that. And then the common ratio. How do we find the common ratio? The common ratio is a term divided by its preceding term. So this divided by this or this divided by this. In each case, you're going to get half, right? So we're going to have 64 divided by 128 is equal to a half. See? So this is my common ratio. So I'm going to carry this, these values and put that into this formula, right? So this means that my T12 the 12th term is going to be equal to, my first term A is 128. Then the common ratio is half, 1 over 2. Raised to power n minus 1, my n is 12, so I put it 12 minus 1. Any problem with this? This is quite interesting. So we're going to have like this. We have 128 times k 1 over 2 raised to power 11. Okay. Now it's a problem. This is a problem. Am I going to leave my work like this? No. I should have to simplify this. So this becomes 128 times 2 raised to power 11. 1 raised to power 11 is 1. 2 raised to power 11 is 2 raised to power 11. Okay? But of course, if you look at this 128, it is a power of 2. We can express it as a number with powers of 2. So now I have 128. 128 is 2 raised to power what? That would be 2 raised to power 7. 2 raised to power 7 times 1 over 2 raised to power 11. So in all, we are going to have 2 raised to power 7 divided by 2 raised to power 11. Okay? So we're going to have this as 1 over, see, 7, or let me write it like this, so you can get it clearly. 7 minus 11, which is 1 over what? 2 raised to power minus 4, which is simply 1 over 16. Okay? This is simply 1 over 16. Or let me write it here, you can see 1 over 16. So you can see clearly, right? So that's it, 1 over 16. Now, that's A part of the question. That's A part of the question. What about B part of the question? The B part of the question says we should find a formula for the nth term. So I'm going to find a formula for the nth term of that AP, of that GP. So B, find the formula for the nth term of this GP. What's the formula for the nth term of this GP? We have what? 1, 2, 8, this and that and that and that. In finding the formula, it means that we can put everything inside except for the n, right? So I'm going to have the nth term, Tn, is equal to AR raised to the power n minus 1. So I'm not going to touch the n. If I'm looking for the formula for the nth term of a particular GP or even AP, I will not touch n. I will just leave it the way it is because that is what determines the general term. So now this is going to be, the first term is 128 times, the common ratio is a half, n minus 1. So I have it, I will just need to simplify this. This is 2 raised to power 7 times, this is 1 over 2 raised to power n minus 1. Okay? So I can simplify this to give me 2 raised to power 7 divided 2 raised to power 7. 2 raised to power 7 over 2 raised to power n minus 1. So this can be further simplified to give me 2 raised to power 7 minus n minus 1. So I will have 2 raised to power 7 minus n plus 1, right? So I'm going to have 2 raised to power 8 minus n. This is the formula for the n term of a GP. Let's look up to the next video. Thank you.